for your project. For function, which is a relationship in which each input has exactly one output. Input values, when we talk about those, we are referring to your x values. And then output values, and that's your y values. And everybody should know that by now if you completed the project. What we're going to do with this today is we're going to be determining whether something is a function or not. And one of the best ways we can do that is by knowing that for something to be a function, basically x can't have two y's. Okay, for example, you can't have a set of ordered pairs that's 1, 5, and then also 1, 7. This is not a function. 1 can't go with 5 and also go with 7. It's just like a relationship. If you have this guy, 1, who goes out with a girl, 5, and this guy also goes out with another girl, 7, how good is that relationship going to work? Not well at all. This is not a function. Okay? You basically can't have repeated x values in order for it to be a function. Okay, so with that in mind then, let's do the first example. Determine whether each set of ordered pairs represents a function. Justify your answer. So we've got our ordered pairs here, 2, 3, 3, 4, 4, 5, 5, 6. And what we're concerned with is our x values. Do we have any repeats there? So our x values are 2, 3, 4, and 5. We know that because x values are always the first value in the set. And so we look, are there any repeats here? Nope. So this one is a function. I'm going to abbreviate that fxn. And justify because there are no repeated x values. Okay. So let's look at B now. 0, 0, 1, 3, 0, 4, and 2, 5. Is this a function or not a function? So again, we're looking to see, are there repeated x values in here? So we've got 0, 0, and also 0, 4. Since that is a repeated x value, this is not a function because we do have repeated x values. Okay, last but not least, I'll let you think about that for a second, but it's a little confusing here for a reason. So you have -1, -2, -3, -2, -5, 0, and -7, 0. Function or not a function. In this case, remember, again, we're only looking at our x values. -1, -3, -5, -7. No repeats. So this one is also a function. The reason that this one is confusing is the y values do have repeats. But when we're in determining a function, the y values don't matter. So this one is a function because no repeated x values. Okay, so that's the first section, is just looking at ordered pairs and determining whether or not they're functions. The next section is looking at a graph and determining whether or not it's a function. Okay, so you can do this out the long way. You can list out, put dots on all of these graphs and list out the ordered pairs like you have here, and then determine if you have any repeats in x values. Or you can take a shortcut called the vertical line test. Okay, vertical line test. And then I abbreviate that VLT, basically says this: if you drop a vertical line anywhere on the graph, is it going to hit your graph in more than one spot on any one line? And if it does hit it in 2 spots, it's not a function. If it doesn't, then it is. So like on here, this is your graph line. And so if I drop some vertical lines on here, let's drop one right here. How many spots does it hit? It hits in 1. If I drop it here, how many spots does it hit? It hits in 1. The question is there any spot on there that would hit more than one spot on the graph? And the answer is no. So this one is a function. This one passes your vertical line test. Okay, contrarily though, you have this one, this graph kind of makes this little whirl around here. And this one now, if you drop a vertical line on here, it hits in 2 locations, okay? So this is not a function. It fails your vertical line test, okay? Even though right here, it would pass it in this one spot, it fails it over here, so overall it fails it, okay? And I'm going to leave the third example for you to try on your own. Remember, functions will only hit one spot for each vertical line. Non-functions, there'll be at least one location that you'll hit twice, or more even. Okay, the last section is probably the most difficult. In that you have to remember some things that we haven't done in a while. So it says, use the description to make a table, then determine whether the description is for a function. Okay, so it says, first we have to translate this. Each output, if you look at your notes above, outputs are y values. So each output, we're going to put y, is equal to 3 times the inputs, if you look up here, are x values, okay? So each output is equal to 3 times the input, so 3x plus 1. And then it says to make a table. So recall, we do this. X is the first column, our function or our equation is the middle column, and then our last column is our y values or our output values. Okay, and if you remember from the beginning of the year, you get to choose your own x values. My advice to you is choose low numbers so that it makes your life a little bit easier when figuring out some answers here. So we're going to go 0, 1, 2, 3. So to figure out our y, we're going to do 3 times 0 instead of x plus 1. So 3 times 0 is 0 plus 1 is 1. And then we're going to do 3 times 1 plus 1. 3 times 1 is 3 plus 1 is 4. 3 times 2 plus 1. 3 times 2 is 6 plus 1 is 7. And you should notice that there's a pattern here. To get from 1 to 4, you add 3. To get from 4 to 7, you add 3. So your next one, to get from 7 to the next one, again, we're going to add 3. Our next one's going to be 10. And if you did out the work, you would figure that out. So this right here makes this linear. And the fact that we have no repeats in our x values here makes that a function. So we say this is a linear function. Linear because this is the same pattern. Function because the x values do not repeat. Okay? And B is very similar. Again, you translate it, each output. So we're going to say y is equal to 2 plus the square of the input value. Square, remember, is a second power. Input value is x, so we're going to say x squared. Again, you would make your table where you do x here, your function in the middle, and your y out here. Sorry, we're getting a little jammed up on here. Again, I'm going to pick my values of 0, 1, 2, 3 here. So my work is going to go like this. 2 plus 0 squared. And remember, you've got to use your order of operations here, your PEMDAS. Before you add, you need to do exponents. So 0 squared is 0 plus 2 is 2. So now we do 2 plus 1 squared. 1 squared is 1 plus 2 is 3. 2 plus 2 squared. 2 squared is 4, plus 2 more is 6. And then last but not least, 2 plus 3 squared. 3 squared is 9, plus 2 more is 11. Okay, now let's check. Do we have the same pattern here going up? This is adding 1, this would be adding 3, and this is adding 5. So this is not the same pattern. So this over here tells us this is nonlinear. And this over here, since we have no repeats here, this is a function. So this is a nonlinear function. Eventually we'll get to non-functions using this part, but this is just the beginning, so that's what we have. Okay, that's it for part 1 of notes today. With you and below, if you don't have it, I did put a link for the homework. The homework is called Functions Number 1. It looks like this, and your job is to do numbers 1 through 12. There's a front and back side. If you have questions on any of this, please come and see me either before school or at lunch.